find the area of the shaded region. Well, the shaded region has a central angle here that's 360 minus 147. So that's actually coming out to 213 degrees. So we've been trying to teach you in class that it's really just, a fractional part of the area of the circle. So whether you use a formula or not, the area of the sector here is basically find the area of the circle, which we all know is 81 pi r squared, and then we're going to multiply that by the fractional part, 213 over 360. And then when we do this in terms of pi, we're getting you to practice with this. You absolutely can just cancel off here, but we are allowing you to use a very powerful tool, the Inspire calculator. Just put this in your calculator, 81 times 213 divided by 360. Do not put the pi in right now, just hit enter, and it will say 1917 all over 40. And then just put a pi on the top because we want to have it in terms of pi, and there was a pi in the numerator here. Don't forget your units, obviously. This would be inches squared because it's an area problem. All right, a vehicle here travels 125.7 feet. So this is how far it's traveling. What you need to understand is that each time it moves along here, like look at this little part here, the circle is going to revolve one time. Really, if I drew a circle at the beginning here, you got to realize that, let me change the color here, like this, and then this circle is going to roll and it's going to hit right here. So to visually show you this, those are equivalent there. You're going to roll it once and you will have a circumference of a circle. Okay, so from here to there is really just a linear measurement. So understand that connection, please, between the linear measurement on the ground to the circumference of the circle. So basically, this whole distance is 125.7, and they told you it revolves 16 times. So there's going to be 16 of these on the ground. So we're going to take 125.7, divide that by 16, and that will equal one of these. Well, we're trying to get you to understand that one of those is the circumference of the circle. So when you do that, I don't have that exact calculation here in front of me, but you're going to have this answer here, but that is the circumference. So when we go to circumference equals pi times diameter here, the circumference goes over here. So 125.7 over 16, which some of you probably have as a decimal at this point, equals pi times diameter. Remember, this is just a number. You know, we can put that on our calculator, get that number. What we want to do is we want to divide by pi. So we're going to take that and we're going to divide by pi. So the diameter comes out to approximately here 2.5 when we round it to the nearest tenth of an inch. So 2.5 inches is the answer to this question. If the same vehicle rotates 200 degrees, how many feet has it traveled? Okay, so now we say, all right, this exact same vehicle is now going to only go 200 degrees. So we know that it's going to go not this entire distance, just 200 degrees of that. So it comes back to the sector length here. So you're going to have a circumference, which remember, the circumference we already found, an exact measure here, 125.7 over 16. That is the circumference of the circle. We found that up here, and we're going to take a fractional part. Well, if it said 180, we would go 1/2, 180 over 360, but it says 200. So we're going to take 200, and we're going to divide by 360 here. So after we do this, you're going to get, fire this in, simplify your fraction, however you go about that, you'll get approximately 4.36 feet. How many feet has it traveled? Approximately 4.36 feet. And hopefully it makes sense that that is less than the circumference length that would be one full turn. Okay, moving along to the pizza problems. Basically, in this question, you have a round pizza with a radius of 25. Be careful, diameter is 50, radius is 25. So the area of the circular pizza here is going to be equal to pi times 25 squared, which we know is 625 pi. That's the area of the circular pizza. Well, we want to take that 625 over pi, and we want to divide that into 15. So instead of thinking technical geometry, arc lengths, and sector areas, we can just do this, and this is actually going to be one slice. So this comes out to approximately 130.9 centimeters squared. Doing the same process with the square pizza, the area of the square would be equal to 53 squared. And when we take that, same logic here, divide by 25. So now it's not the area of the square, but it's the area of one piece. And we're going to get approximately 112.36 centimeters squared. So which one is obviously has the greater area? It would be this one. And then for the part B, how much bigger is it? Well, the 139 minus the 112.36, and you're going to get your 18.54 centimeters squared. That's a rounded answer there. Down below, this is kind of a unique problem. See if I can highlight what's going on here. Maybe this will be the highlight of the video, I'm not sure. But basically, we have, for area, it's pretty straightforward. And maybe I should start with that. Let's start with the area. The area is going to be equal to find the large minus the two small ones. Now, the diameter of the large is 16. So that means this is 8, which means the radius here is going to be 4. So the large circle has a radius of 8. Okay? So that's going to be 64 pi for the large circle. All right, area of the small one, sorry, pen's messing up a little bit here. Area of the small one is going to be equal to 16 pi. So logically with the area, I hope this makes sense, so you're going to take the area, or to find the area of the shaded, we're going to set it equal to, well, the large one, which is 64 pi, and we're going to subtract the two small circles, so that would be 32 pi. So this is going to come out to 32 pi, what are our units here, centimeters squared. So I think I usually don't have kids that have a lot of trouble with that. That one's pretty straightforward. But the perimeter doesn't work the same way. A lot of kids want to do, okay, let's do perimeter of big minus perimeter of small. It just doesn't work. You have to follow this around. All right, let me get a highlighter. Follow this around here. Make the highlighter a little bit larger here. I'm going to trace the perimeter of the shaded here. It's going to be here, and then it actually bends up here, and then bends around, and it actually does that on the other side too. We're looking for the perimeter of the shaded. And by now, I hope you're realizing that the perimeter of the shaded is actually just one big circle, circumference, and then both of the circumferences of the smaller circles. So think of it in that light. The circumference of the large circle is pi times diameter. So the circumference of the large, pi times diameter, the diameter is 16. We know that that's actually 16 pi. Then the circumference of the smaller one would be 8 pi. So, running out of space, circumference of small here is actually equal to 8 pi, pi times diameter. So if you add the two small ones together, you get 8 plus 8, which is 16, and then we add the large 16. You know, the perimeter here is actually equal to 32 pi as well, but it would just be centimeters. All right?